Hey everyone, just a little bit extra here for those of you who want some spicy. We talked about square roots that multiply together to make a square number. Most of the time we think about that, our brain goes toward integer values or numbers that we're quite familiar with. So 5 is a whole number or integer, times 5 again. Here my square roots are integers. Those are called rational numbers. However, down here we have the square root of 10. Remember, that was that infinitely long decimal with no pattern to it, which would take forever to write down, and it's not very convenient. These numbers, like square root of 10, that are inconvenient to write down and go on forever, are called irrational numbers. The beginning of the word rational starts with ratio. Ratio is another fancy word for fraction. A rational number is a type of number that could be written as a fraction. Here are a whole bunch of examples of rational numbers, although they are not currently written as fractions. With a little bit of time and effort, I could convert any of these into a fraction. Then we have this other type of number called irrational. An irrational number cannot be written as a fraction, ever. If you were to try to write irrational numbers as decimals, they will always be infinitely long without any pattern. The most famous irrational number that you've already learned about is pi. Right? Many of you have memorized a bunch of digits of pi, but if you look into it, pi never ends. I think we've calculated with computers over 1 trillion digits of pi now, and it still shows no pattern and it shows no sign of ending. The square root of 2 is another number that is irrational. So you can't think of a whole number times itself that equals 2, nor can I. And if we start estimating with decimals, 1.4 times 1.4 gets us to 1.96. That's pretty close. But if we look into it for longer and put more effort into it, we find that the actual square root of 2, so a number that multiplies by itself to equal 2, would be infinitely long as a decimal without any pattern to those decimal place values. Not all square roots are irrational, right? The square root of 16 is actually a rational number because if you think about it, you'll come up with a whole number that multiplies by itself to equal 16. So the square root of 16 is just a fancy way of writing the number 4. 4 we can write as a fraction in lots of ways, 8 over 2, 20 over 5. It doesn't matter what kind of fraction it is, just that it can be written as a fraction. So again, most of the square roots that you will think about are rational numbers. However, the majority of square roots in the world are actually irrational. Just think about the numbers from 1 to 20. Can you come up with perfect square root values that would equal all of the numbers from 1 to 20? So 1 times 1 is 1. There you go. There's a perfect square root. That's a rational value. 2 times 2 is 4. Right? 2 and 2 are whole numbers. Those are rational. 4 is a perfect square. So we did it again. But we skipped 2 and 3. 3 times 3 is 9. 3 and 3 are rational numbers. 9 is a rational number. But we just jumped from 4 as a perfect square up to 9 as a perfect square. What about 5, 6, 7, 8? If we start thinking about the square roots of those numbers, we're going to come up with all kinds of irrational values.